Hello, and this will be my attempt to explain how to dock easy and with style. No suicide, burning, and net nonsense. You shall not find those here. Or you'll find me failing and failing again, which will hopefully also be fun. So, what are we going to be doing? Well, let's check the Space Center. Come on, load. No. Basically, we'll be docking this thing, which is, well, you'll see. With this spacecraft, which is in a pretty circular orbit. What is this? 265 kilometers up, which is nice. So, without further ado, let's get to our probe, with which we'll be doing the docking. Oh, I forgot. Let's go to the docky probe, so to say. The space station we'll be docking to, which is nothing more than a simple ferry that I use to ferry goods from Kerbal orbit to Munar orbit. Where is it? Ah, there it is. Look at this beauty of meshed together components. And so, why am we here? Well, first thing first, before doing any kind of docking, what you want to do is to align, we'll be docking at this spot here, to align this spot with either so it points directly north or points directly south. Why? Well, it's simple. Uh, if the port is pointing directly north or south, it will not move from that head. Oh, I'm terribly loud, I think. It will not move from that heading during the orbital maneuvers. If it were to be pointing straight up, it would rotate during revolutions around the carabin. But this way, you always know that it's pointing at 000 heading. And that will make our docking a lot easier. Or I will fail harder and harder. So let's get back to our probe we should be using for the docking. Let's see. No, I don't want to see my gazillion of landings on the moon. Docking test, fly. And this will be the thing that will be docking. Actually, it will be this part here. We'll detach the rocket once we are close enough. And we kill our relative velocities. But pretty much we'll be docking this. Supposedly, let's fluff it up. We want to refuel the RCS tanks on that thing. So I have some RCS tanks here. Also, it will make it easy if I screw something up. I won't have to reload or something. Something to say about this probe. Main thing is to know that where did I position my RCS transistors? They are actually pretty symmetrically positioned around the center of the mass of this spacecraft, which is relatively here. And that is one of the most important things you need to do on your spacecraft before you attempt any kind of digging. You need to position your RCS thrusters so that they are symmetrical compared to the center of mass, at least where the center of mass that will be at the point in time you're docking. If they are not symmetrically aligned with center of mass, you will have extreme amounts of what I call wobbling when you try to rotate or translate in orbit using RCS thrusters. But this should be a pretty stable craft. Also, it's quite small, and considering how much RCS I have, and considering how much leverage this will probably provide, quite nimble one also. So what is our first task? Well, let's check the situation. Okay, let's kill the flight engineer. Flight engineer. By the way, this is pretty much an unmodded Kerbal Space program. Most of these mods are more or less UI mods. Tug fuel balancer for transferring fuel, alarm clock for alarming me, Kerber engineer, and docking alignment indicator, which can be used for docking, but will be turning off. I'll be doing the docking using good old eyeball Mark 1, so to say. So this is our probe. We are in a pretty circular, let's just check, circular 100, no, not vessel, not service, orbit. Pretty circular 100-kilometer orbit. And our target is in, let's set the target, is in a 265-kilometer orbit. First thing first is to align our orbits. If you rotate like this, the map, you can notice that that our target has a serious inclination compared to us. What we need to do is align our orbit to theirs. So what do we do? Well, we check the first next descent or ascent node, where we need to do the correct correction maneuver. Add the maneuver node there. And then since this is an ascent node, that means we are from this point on ascending compared to our target, we need to burn downwards to align our orbits. So when you see the ascent descent indicators start to move slowly, you need to slow down and gently bring them so that they indicate 0, 0 degrees. So we'll need to burn 147 meters per second. Okay, we can do that. Let's time warp there. Check this thing. I have delta V of 1500, 137. That's something like 100 seconds, right? 100 seconds divided by this by that. That's 1.5 meters per second, right? No, 15 meters per second. Okay, I'm terrible. It seems. 50 meters per second. So that move. Take a break. I'm already fudging this up. Start burn. Start the burn. Stop. Slow. Let's see what do they do. Me minus 0.2. Well, I think I can correct it at a later date. So the next so for now we shall leave it at 0.2. Next thing that we want to do is to put, in this case, our periaps to be on the target orbit. And we essentially want to choose where we will be doing docking. Since I want to be doing the docking on the sunny side, we'll be burning over here. Actually, I think I can find descent planar corrections with this burn. So let's put it on descent node. Let's rise our apoaps. Rise. Up. and we have our meeting. Oh, don't worry that we don't have a full meeting. We'll be doing these corrections afterwards. And also, this is a descent node, thus we want to do the ascent. Oh, excellent, excellent, excellent. And let's align our spacecraft with our burn vector right now, so I don't need to do it later. That's pretty much it. And time. Let's start burning at 5-second mark. Let's see what we have here. So I think we are going a slight bit too quickly. I want about the as close as possible to the target orbit, so that our two intersects are as close as possible. Let's lower this thing a bit down. Let's, that should minus 0.2. For now, let's do it this way. So, now that we have an intersect of sorts, and we are touching the orbit, let's see what's our situation here. Let's remove the nav ball for now. Let's see. So we have one intersect here. Will be here, and our thing the probe will be meeting will be here at this position. So essentially, we want to catch up to them, and same thing is here, which is logical. So catching up and being caught up. Well, our current setup is pretty much excellent for that, for catching up. When you have this kind of situation where your intersect is behind, where you are essentially behind the probe you are trying to dock with, you want to catch up, right? Because you will be here, and the probe and our station will be here. So we are behind them, thus we need to catch up. How do you do that? Well, you put yourself basically in this kind of orbit. Your periaps is lower than their periaps, and your apoaps is basically on their apoaps. So that you gain speed here. And that speed allows you to overtake the space station you want to dock with. And that was exactly what we will do. We'll do one revolution here. We'll come here, and the spacecraft, the space station will be here while we are here. Then we shall do some course adjustments, and hopefully on the next revolution we'll be exactly where we want. Close. Also, if you are doing this method, our final orbital adjustment will be very low, so we won't need to do any suicide burning. So let's see, in the not this orbit, this first orbit, in the second orbit, the target will be here and will be here. That means I need to catch up. Basically, we would overshoot the target, so we need to slow down our overshooting. Look at how the target position indicator and our intersect are moving closer and closer as I raise my periaps. let's see, 1.3 kilometers. We can do better. I need to, what is now 2.5. And I think the big 0.6. I think that's pretty much on the money, so to say. Let's see, this is the descent node. Maybe we can prod it a bit. Let's see, 0.6. Okay, let's leave it at that. So let's see what happens now. This is our target. As you can also see right now, we are catching up to it because we are in a, so to say, lower orbit. And here, it's now the space station is before us. So that's why we're doing this whole catching up business. Let's see, let's bring up this thing. Okay, we are pretty much aligned already. And see, we are only moving with by 57 meters per second. All small and quick burns. No suicide burning here at the last possible moment, trying to nullify hundreds of meters per second. Let's not overdo it. Nine, four, five. And let's do the rest of the course corrections using RCS because we need small course corrections. Essentially, I'll be using translation controls. So H and then by default for forwards and backwards, J and L for left, right, I and K for up and down. So I want to, let's try going forward. Yep, I'm holding down forward, and you can see our separation is slowly decreasing. Let's see how close. 0.3, 0.4. No. Maybe press caps lock for finer control. Let's leave it at 0.2 kilometers, 200 meters. We are practically at spitting distance in orbital terms. And let's just demonstrate how low our final orbital correction will be. Essentially, at this point, we'll be doing, we'll be burning forwards. Let's see what will happen. And this pretty much aligns our, so to say, and 55 meters per second is nothing. I can do such a burn using RCS, so it will be pretty gentle braking in order to meet with the space station. So let's speed up. And as you can see, we are doing the overtaking. We are slowly approaching. Our distance is dropping. Because we are in a lower orbit. Let's see what this is now. Can we see now? It's still 27 kilometers away. 24, 23, 21, 14, 15, 10. Let's. Where is. Okay. Now, when you do this final orbital burn, you want to basically brake and stay close to the target. You want to switch your nav volt to target mode. So it only indicates the velocity vector compared to your target. Essentially, when we close the gap, so to say, when we get close enough to Satara 1, our space station that we want to dock to, we want to kill our relative velocities. And we'll do that simply by pointing our nose, so to say, retrograde compared to our relative vectors, and kilo that relative speed. So as you can see, I've pretty much aligned too. And you can also see the space station mark here, this triangular thing here. So let's see. Oh, we are approaching. Let's save, so we have a point to return to. Let's hope it doesn't try to auto-save in the middle of there we are. 600, 500. Let's start burning. Burn, and we can do the rest via RCS. And I want this indicator on my nose, not here. There we go. And let's ditch the rocket that brought us here. And now the only thing that we want to do is basically align ourselves with the... No, that's... this is the direction forwards. And let's use the RCS to close the distance. 3 meters per second is fine. Let's use translation controls to align ourselves with the station. Let's speed it up. Also, I think we are coming from the north, so we should be pretty much aligned properly for the docking. Well, mostly. Let's do some braking. Okay, let's brake completely. One thing that I never really realize is what is my orientation in space. That's one of my many fallen feelings as a Kerbal engineer. So, now that we are pretty much close, let's kill this velocity. I want to show you something. Sorry for that interrupt. Well, I'm probably breaking your ears right now with the noise. So we are pretty close to our destination. Now what we want to do is to align ourselves with the direction of the port we will be docking to. If you remember from the beginning of the video, this port is aligned so it points northward. So what we want to do is point this thing southward. That's the heading 180. And here it is. Next thing that we want to do, we want to translate, and you can see on the nav ball our space station is over here. Can you see it? This is running in windowed mode, but I wonder Is it recording it? I hope so. Anyway, you see this, you should see a, let's say, pinkish, I'm terrible with colors, circle on the nullball. That's our space station, as you probably already know. So let's rotate so it's to my left, simplify, and let's move towards it. Let's align us. You'll notice that I'm only using translation. From now on I will only use translation, RCS controls, no rotation, no such nonsense. We should be getting pretty aligned. We'll do final alignment when we are pretty much on the station. The view is horrible. Okay. Let's move a bit down. Is it downwards? Yes, it's downwards. I think it is. Is it? Oh, yes, 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 it is. No. Be a nice. Let's kill our speed. Hopefully. Okay, let's simplify things by going forward. Now let's align our. Do these course adjustments because I want to move a bit forwards. I put my velocity indicator behind the space station indicator. So let's, now we are pretty much aligned. Let's do the alignment. The alignment dance. Let's hope I'm up, and docking. Docking achieved. And let's transfer our fuel to complete our mission. Mission impossible. Let's see. I want to fill this fuel tank here. I think it's this one. Yes, this one. Transfer in, and let's do it at Mach 1 speeds, so to say. And let's fill this one in also, and let's fill up. What other do I have? I think this is also, yes. So this 101 is also should be filled up. What's this one? Highlight. Yeah, why not? Transfer in. Well, that's a problem. Let's fill one of them, one of these two tanks to the half mark, so to say. Transfer in. Stop. 47, yeah, that's pretty much it. And let's undock. And let's try. We switch to our. Let's. Oh, yeah, this is the wobble I was talking about. Because now we are a bit. We are not the RCS thrusters are not aligned with the center of mass, since this fuel tank is nearly full and this is completely empty. You can see the slight wobble because these are small masses and RCS can overcome it easily, but you can spot the wobble, and that's why the symmetry is of the utmost importance when doing docking work. Oh, so why did I do this? I think it's pretty much simple, really. I wanted to demonstrate how in some ways it's easier to dock using docking and alignment indicator. Let's control from here, and let's move back to our space station. that's it. Burn forwards with RCS using H and N. Align it by pressing by moving the vector indicator left and right with J and K. Oh, let's balance the fuel. Balance, I think it's this one. Balance. Balance. No, I don't want to do that. Thank you. Why did you turn yourself off? Crazy space stations. Anyway, let's do it. Let's do some braking. Actually, let's. What am I trying to do? Let's overshoot a bit. Let's stop here. Oh, how it's easy when you do it with light spacecrafts. Do this with light spacecrafts such as this. And let's kill our velocity. Yeah, that's it. So, and let's give it a bit of a problem with this station. Okay, putting it in this direction, placing it, putting it. So it's no longer aligned with the north south, thus making it a more difficult target. Let's go back to no, that's it. You. Let's select our docking clamp as point of view. Let's select our target as this thing here, and now docking indicator pops up. This is a nice mod that I found on Cable Space Parts. It's essentially a Navy docking port alignment indicator, something like that. And why is it useful? Because you can align yourself with the docking port easily and do the docking quite easily. And it does no automation for you lovers of hardcore cannibal, so no whining please. It only provides you with the information you still need to do docking on your own. So what are these yellow, green and such markings? Well, the big yellow circle is basically where you are pointing. Well, essentially, it's your alignment indicator. Are you aligned with the direction at which the docking port is pointing? So let's align it. We do this by rotating, of course, up, rotating. W moves it upwards, S moves it downwards. It's a bit finicky and a bit counterintuitive, but you get used to it in a while. Let's move this thing here. Okay, so now as you can, if I could move the camera properly, I could show you, but since the camera is being uncooperative, there it is. We are pretty much aligned, as you can see. Well, we are aligned in the terms of the course, so to say. We are not aligned in the terms of translation. I still need to move downwards towards it. And that's what this other indicator, these lines are for. These lines basically indicate where the station is. And we need to align the green lines with the white lines, of course, and we do this with linear translation controls, no rotation anymore. As you can see, this small yellow indicator is basically our speed vector, and it shows us which direction we are heading at. So I place it in the upper left quadrant to move upper left, and it starts to move us. Let's decrease the speed. Let's kill first this. the line so we don't lose it and overshoot. Okay, I think everything is going to be fine. Break, 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 break. Stop, stop being. We are pretty much aligned, so let's move forward. C-vel that you can see here is our velocity in regards to our approach and closing velocity. Essentially, it doesn't record the actual velocity between you and the target. It's so to say velocity in terms of your it's the velocity along your alignment, so to say. Because if I move left to right, as you can see, it doesn't change the relative this linear velocity. It's the velocity how quickly you are approaching or retreating from the docking port. I probably made a mess of it, didn't I? Oh well. You'll soon figure it out. And final and there it is. And we didn't need to align north-south. This can be especially usual when mounting, let's say, radial engines on your too big to move space station and such, because those are unlikely to point northwards and southwards and such. So this is it, I think. This is what I can show you of docking. The only other thing I can show you is when you want to make the space station you are trying to dock to catch up to you. And it's also simple, really. You basically put your orbit. Let's turn on the SAS, turn on the SAS. Let's break orbit from it. Let's kill some of that velocity. And let's show. So let's say, hypothetically, our space station is behind us. And we want it to catch up to us. So how do we do it? Well, basically, last time we were doing the catching up, we placed our apoaps at target orbit and periaps below it. Now we shall place our periaps on the orbit and our apoaps above it, and you shall see that the space station will start moving more quickly than we do, and we shall do it quite simply by burning forward. How much RCS? Oh, plenty. Let's see how much can I change my orbital velocity? Probably by quite a bit, considering how high we are. Let's keep an eye on RCS. Let's put it at 325. Let's go. Now what you'll see here is that the space station will start to overtake us. It will be moving more quickly than we do. Well, quite slowly because our orbits are not that different. I think that docking test is no, we are the probe and they are the spacecraft. Yes, because there is a carabin in them. Carabal. You know, Ritter Green Man is in it. And you can already see the space station is moving faster now. So go to, let's say, higher. This is a higher orbit. If you want the space station to catch up to you, or go to a lower orbit if you want to be caught up to. Actually, let's try doing it. Let's see, how much speed would I need to catch up with the space station? Probably, let's see, kill the velocity. Oh yes, target, set as target. Let's see what's going on here. Target position, intersect. Oh, there it is. So not much. Forward, backwards. There we go. That's 9. Is it 0.7 or 9.2? 0.7. Excellent. So if we can burn 70 meters per second, change our velocity, we should be able to catch up to the space station because we will be going in a lower orbit, thus going faster and catching up. So let's. I don't even know how quickly can I accelerate using RCS, but let's try with 10-second burn. And let's load ditch the indicator. We'll be doing this eyeball by Mach 0.1. So let's burn reverse, I think. Yes, reverse. Reverse the polarity of photon flow, so to say. Okay, and soon. Okay, can you see it? As we are putting our periaps lower and lower, the space station, this is where the space station will be. No, this is where the space station will be. The space station is getting closer and closer and closer to us. Although I don't know how much. Can I get a closing card using only RCS? Oh, not bad. Oh, not bad at all. 0.3. There. Simple as pie, I guess. But we want to deorbit, so let's try deorbiting this with RCS on. And I think this is going to take some time. So this is basically it. This is all there is to say about docking and intercepts and such things. It's not that complicated. Oh, one other thing. It's quite simple, really. When you are planning to dock something, I recommend that you start the launch after the space station has passed the Kerbal Space Center. Actually, where is the Kerbal Space Center? Kerbal Space Center is probably somewhere around here. So let's say that Kerbal Space Center is over here. I think you would want the space station to be somewhere around here, about 45 degrees of from the Kerbal Space Center, because essentially when you are launching, you are already in a lower orbit. So by the very fact that you are launching, you will be catching up to a space station. So there you go. Also, I prefer to catch up than to be caught up to, because this way the very atmosphere of the Kerbal limits how much I can go below the target orbit, and thus it prevents me from doing stupid high energy intercepts where I need to kill hundreds of meters per second relative speeds. It's simply a measure to contain our megalomania, so to say. Because when you are going in a higher orbit, you cannot really eyeball it how much of a speed differential you will be getting. 7, 5, 4, 3, and let's watch it streak across the night skies of Kirby. Full speed ahead. 45 minutes. me blathering about stupid things. Well, not stupid things, but I have a feeling that I've been blathering about and haven't been actually explaining anything that people already knew, didn't know already. Yes, you knew this already, so nice for you. Why isn't the music? Why did the music stop playing? I want some graveyard march or something like that. We are seeing a brave pro die for science, I guess. Although we'll be not getting any science from it ever again. 4,000, 3,000, 2,000. Oh, we are practically going. Can I reduce my speed? Probably could land this thing if I started burning earlier. So, that's it. Fly safe or crash amusingly for you, of course. And we'll probably see him somewhere, I don't